Hey there, everyone. My name is Dan Cameron, and I'm the owner of the Strength Coach Tutor. Today, we're going to go over calculating target heart rate ranges. All right, and so there's two methods to do this. There's the Karvonen Method, and there's the percentage of maximal heart rate method. And we're going to go over both of those today. So why do we do these calculations first off, right? Why do these matter? And so these target heart rate calculations are matter because they're used to determine the intensity to train at for any type of cardiovascular or endurance activities. If you're a swimmer, long distance runner, cyclist, whatever it may be, any type of endurance activity, this is where it's important. And the formulas used for these calculations are also age dependent, meaning that they take into consideration your age. And so, of course, the intensities that you're going to train at are going to vary based on your age as well. And so that's how it also becomes a little bit more individualized as well, rather than just saying, train at 50%. Well, 50% for one person is a lot different for 50% for another individual, right? Everyone's going to have different needs, and especially everyone's going to have different aerobic capacities and capabilities. And so by taking age into consideration, it makes it more individualized. So the formulas. So the two formulas are the Karvonen method and the percentage of maximal heart rate method. All right. The Karvonen method is definitely more involved. There's an extra step to it. But the percentage of maximal heart rate method, in my opinion, is pretty straightforward. Both of these aren't necessarily hard to do, especially if you do have a calculator, of course. But, on the exam, we do not have a calculator. And I'll walk with you guys step by step on how I would do these and how I would do the math on my own with a pencil and paper, right? And so let's look over these formulas first, though. So the Karvonen method, you first have to find the age predicted maximum heart rate. And that's the first step for both of these formulas. And all that requires you doing is doing 220 minus the individual's age. So if you're 20 years old, you do 220 minus 20, and that would be 200. For the Karvonen method, your second step is then to calculate the heart rate reserve. And heart rate reserve is pretty straightforward. All you have to do is age predicted max heart rate minus their resting heart rate. And then third, and this is usually the hardest step for most people, including myself, is that the target heart rate, to calculate what heart rate you actually need to be training at, you have to do the heart rate reserve times your intensity plus your resting heart rate. And so when they give you the intensity, it's always in the question, it's always given as a percentage of your maximal heart rate, right? So say, I want to train at 50% of my maximal heart rate. Well, you're not actually going to do your heart rate reserve times 50. You get to convert that percentage into a decimal, right? So 50% is 0.5 when expressed as a decimal, right? If I want to train at 65% of my maximal heart rate, the decimal would then be 0.65, right? So I have to do the heart rate reserve times that intensity as a decimal. I do that calculation first, right, because it's in parentheses. And then once I get that number within the parentheses, then I add on the resting heart rate. Now, step 3, you have to calculate that twice if you're given a range in which the athlete or individual is trying to train at. So if they're trying to train at, let's say, 50 to 60% of their maximal heart rate, you would have to then plug in 0.5 to get 50%, what that heart rate is to train at 50%. And then in order to get 60%, you do the same procedures, except now instead of 0.5 as your intensity, you now plug that in for 0.6, okay? And so those two numbers you get are your target heart rate range when using the Karvonen method. For the percentage of maximal heart rate method, again, that first step is to calculate your age predicted max heart rate. Pretty straightforward. It's just 220 minus your age. And now next part, pretty similar concept for the most part compared to step 3 here, but with step 2, for the percentage of maximal heart rate method, you just take your age predicted max heart rate times the intensity. So intensity, same thing here. If you want to train at 40% of your maximal heart rate, you convert that 40% to 0.4, because again, we're not going to multiply by that percentage number. We have to convert that to a decimal. So whatever my age predicted max heart rate is, I multiply it by that intensity when expressed as a decimal, and then that would give me my target heart rate. And again, if you're given two intensities in the question, so if it's 40 to 50%, I'd have to do age predicted max heart rate times 0.4, and then I'd have to do age predicted max heart rate times 5 in order to get that range. And that's what I'm mostly going to be looking for in a lot of these questions. So we'll go over an example of the Karvonen method to start, and then we'll go over an example of the percentage of maximal heart rate method. So with the Karvonen method, here's the question. So a 45-year-old distance runner is looking to train between 60 to 70% of their maximum heart rate. Their resting heart rate is 60 beats per minute. Using their Karvonen method, what is their target heart rate range? All right. So again, I have the 3 steps listed throughout here in white, right? So if the age predicted max heart rate is, that formula is 220 minus age, right? Well, in the question, they tell us that the individual is 45 years old, right? So I have to do 220 minus 45. That's where I'm getting that 45, right? You should be able to do that math on paper or in your head without a problem. And with that, you get 175 beats per minute. With heart rate reserve, now all you have to do is do your age predicted max heart rate, which we just found out in step 1, right? That was 175, and your resting heart rate. And in the question, they give us the resting heart rate. They have to give you the resting heart rate in the question for whenever you have to calculate the Karvonen method. They will give you that. So your resting heart rate is 60 beats per minute. So you'd have to do 175 minus 60. So therefore, your heart rate reserve is 115. All right, and again, so if you ever get caught in a question and you're trying to figure out, oh, what's their resting heart rate? They didn't give it to me in the question. Maybe you need to reread the question because maybe they're not asking for the Karvonen method. They may be asking for the percentage of maximal heart rate method. All right, so if no resting heart rate is given, you're gonna and it should tell you that you're going to be using the percentage of maximal heart rate method. So make sure you read carefully there. So again, with step 2, we just found our heart rate reserve at 115 because we subtracted the age predicted max heart rate into the resting heart rate. So again, the 175 came from step 1, and the 60 was our resting heart rate, and that was given to us in the question. Now, this is the part that a lot of us have more difficulty with. So we have the target heart rate. We know target heart rate equals heart rate reserve times intensity. We do that first because that's in parentheses, plus the resting heart rate. So if we look back at the question, it tells us that the athlete is looking to train at 60 to 70% of their maximum heart rate. So that's our 2 intensities. We know we're going to have to plug in 0.6 and we'll have to plug in 0.7 into that equation there. All right. And resting heart rate will stay the same, right? Because resting heart rate is still going to be 60. So let's do 60% first, right? So if I calculate target heart rate, I do 115 times 0.6. That's going to get me 69, right? So target heart rate, then I would do 69 plus 60 and add those 2 together, and that would give me 129. That's my target heart rate if I'm training at 60% of my maximal heart rate. But I still need to find 70, so I repeat that process again. But now you can see I'm going to do 115 times 0.7, and so that would get me 81, and I'm going to do 81 plus 60, and then that would get me 141. And so my target heart rate range, the range at which my heart rate can fluctuate when I'm training in between that 60 to 70% of my maximal heart rate, that's going to be 129 to 141, right? Because I got 129 using 60%, and I got 141 using 70%. Now, of course, the problem is I have no idea how to calculate, what's 60% of 115. I don't know how to calculate what's 70% of 115, right? And off the top of my head, I don't know how to do that either. But what I'm going to show you guys here is what I call the 10% rule. And we're going to give an example of what that looks like. So I'm going to just give me a second, copy and paste this. I'm going to pull up my whiteboard here. All right. So this is what we just found out before, right? This is what we were just doing. So this is how I do the 10% rule. So we're going to do 60% first. We're going to figure out how to figure out 60% of 115, all right? So what I call the 10% rule is it's always easy to figure out 10% of something, right? You just move the decimal over 1 spot. So I can easily figure out 10% of 115, right? 10% of 115 equals 11.5, right? Because I just moved the decimal over 1 spot. The decimal would be here, right? But all I did, I just moved it over to the left 1 spot, and so that gives me 11.5, okay? So if I know 10% is 11.5, but I'm looking for 60%, I then have to figure out what is 6 times 11.5. All right, and you can figure it out like that. Usually if I'm looking at this right now, right, I pretty much know 11 times 6 is going to be 66, right? 11 times 6 is 66, but you still have the decimal to deal with, right? Remember, if it's 0.5, that always just means half of something, right? So half of 6 would be 3. So I can just add on the 3 there, right? Because I didn't calculate that before. I did 11 times 6, and now I'm doing 0.5 times 6. So that'd be 66 plus 3. And so then, therefore, that would equal 69. There we go, right? And again, when I used a calculator before when I was creating this, I got 69, right? So I'm right on the money there. Now let's look at 10% rule for 0.7. So again, we're still looking at 10% of 115, but now we have to figure out what 7% is, right? Or 70%, excuse me. So we're multiplying by 0.7 times 115. So instead of doing 6 times 11.5, I now have to do 7 times 11.5, all right? So this is going to get a little bit trickier, right? Let's walk by this, right? So if I do, I'll separate this out a little bit. So if I do 7 times 11, that equals, of course, 77, right? But now when I do 0.5, if I do 7 times 0.5, well, still, same idea. You have to figure out what half of 7 is. And half of 7 is 3.5, right? Half of 7 is 3.5. So there you go. Okay, but now it's like, okay, now what do I do? But remember, so we split up that 11.5. We did 7 times 11, and now we did 7 times 0.5, okay? And so now I still have to add that 77 plus the 3.5. And what that gets me is 80.5 plus, which really, if I round up, is 81. And that's what I got right there. That's what I get in my target heart rate range, right? And so from there, I can do simple addition and figure out the rest of my equation. But to me, whenever you have a weird decimal that you have to work with, I like using that 10% rule because it makes the math a lot more simpler and more straightforward. All right, and I hope this helps you guys out. And we'll do the same thing for when we get to the target heart rate method next. All right. So let me stop sharing this. And this should say percentage of maximal. Excuse me, apologize about that. All right. So we have the percentage of maximal heart rate method. We have a 30-year-old distance runner looking to train between 55 to 65% of their maximum heart rate. So it's going to get a little bit tricky here, right? These decimals aren't as straightforward. So using the percentage of maximal heart rate method, what is their target heart rate range? So again, first step is the same. We got to figure out that age predicted max heart rate. Now in this question, right, they're 30 years old. So instead of, well, in the previous question, they were 45, but now in this question, they're 30, right? So now I'll do 220 minus 30, right? And that's going to give me 190, all right? Now we have to multiply our age predicted max heart rate times our intensities, right? And again, this is a situation where we have to do this equation twice, but change the intensities. So for the first part here, I'm going to do 190 times 0.55 because 55% converted as a decimal is 0.55. And target heart rate is 190 times 0.65, right? Because 65% converted to a decimal is 0.65. And so there, you know, I would get 124. In the first question, I got 105. So those two numbers would give me my range. And so my target heart rate range at that intensity would be 105 to 124 beats per minute. All right. Now, of course, again, not so straightforward because now these percentages have a 5 in them, right? It's not just 0.5 and 0.6. It's 0.55 and 0.65. And that's going to change things a little bit, and I'll show you how. One moment. Okay, so I apologize. What was my my age predicted max heart rate was 190. Right? Yeah. Okay. So my 10% rule, right? So I have to figure out in both of these questions what 55% of 190 and what 65% of 190 is, right? But first, in order to make this a little bit easier on myself, I'm going to figure out what 10% of 190 is, right? So 10% of 190 equals 19, right? Again, I'm just moving the decimal over to the left one spot. So I went from the decimal being on the right here to now it going over to here, right? To in between the 19 and 0. So therefore it's 19. 10% of 190 is 19. Now the trickier part is though, that's giving me 10%. And so if I had 50, that would be super easy to calculate. But the fact is that I also have 0.05 to deal with as well. And so what I'm also going to do, in order to figure out that 0.05, right, because now we have 55 and 65, in order to figure out the 5 on the right side here, I'm actually going to figure out what is half of 19. So 19 divided by 2 would equal, 19 divided by 2 should be 9.5, right? Yep. So 9.5. So that's going to become important for these 0.05s, right? And you'll see this in a second here. So let me see if I can shrink this a bit. All right, so let's figure out what is 0.55 times 190, right? So I know my 10% rule, 10% of 190 equals 10% of 190 equals 19. So if I want to figure out that 50%, I'd have to do 5 times 19, and then that would equal, let's see, so 5 times 10 is 50, and that's 45. So that would be 95, and I'll use a calculator just to double check, but 5 times 19 is 95, right? But again, that's just getting me 50% of that. I'm looking for 55. If I'm doing, in order to get my 0.05, that what's left over there, I need this 9.5 from before, all right? So I'd have to do 95 plus 9.5, and that would equal, let's see, that is 104.5, which would then equal 105, all right? So again, I did 5 times 19 because that would get me 50%, right? Because 10% of 190 is 19, but I'm looking for, right now I'm looking for 50%. I know I need 55, but I'm looking for 50. And so I'd have to multiply 19 times 5, and that got me 95, right? But I still have that 0.05. I still need the 5 out of the 55 left over. And that's what I did here, right? Because if 10% of 190 is 19, in order to get 5%, I need to divide that by 2, right? And so 9.5 is that 5% that's left over. So I have to add the 50% plus the 5% in order to get the whole 55%. All right, I know that's a crazy way to go about it and everything, but if you can't do long division, to me, this is the easiest way to figure it out. All right, so now let's do the same thing for 65. All right, so again, if I have, I know 10% of 190 is 19, so I'm working with 65% now. So I'm going to first start off by doing 6 times 19, and what that would equal, 16, 6 plus 1 is 54, that would be 114, and then again, that 114 is giving me the 60%, but I still need that last 5%, and again, this 9.5 is giving me that last 5%, so I'd have to do 114 plus, what is it, 9.5, and that would give me 123.5, oops, which then equals 124, right? And so that's how I would solve that. So another way to think of it, right? Let me write this out a little bit more simply here. So if you want 5%, divide the 10% number by 2, right? So what I did here, right, again, I got 10% of 190, which is 19. In order to find 5% of 190, I'm just going to divide that 19 by 2, which was 9.5, and that's how I got that 5%. And so instead of trying to do 55 and 65 times 0.9 times 190, excuse me, I first figured out what's 50% of 190 and what's 60% of 190. And then once I figured that out, I added on that 5% at the end. All right. And that's how I got these numbers here. All right. If you guys have any more questions or need further assistance, you can always, of course, reach me at thestrengthcoachtutor.com for any further assistance when you're studying for the NSCA CSCS exam. Again, my name is Dan with the Strength Coach Tutor. If you guys need anything else, please feel free to reach out at any time. Thanks.